Welcome, everybody, to the Measuring Progress Toward AGI Hackathon live stream. Thank you for taking the time to join us. I know we have folks from all over the world, and it may be an odd time for you right now, so we really appreciate you being here. So it's the first time we're doing a live stream midway through a hackathon, so please bear with us if we have some slight hiccups. We're trying our best, and we can assure you that we will have a great session ahead. Recording will be shared with you after this, so you can rewatch it or share it with your friends who couldn't be here today. All right. In terms of presenters today, I'm Nick. I'm a product manager for Kaggle Benchmarks and our agent eval initiatives. I'm focused on making the benchmark creation, execution, and discovery process as easy as it is for you. And I'm also the co-host of this hackathon alongside my colleagues, Ryan and Oren. Ryan?
Yeah, hi everyone. I'm Ryan Burnell. I'm a research scientist at Google DeepMind in the Gemini evaluations team and a co-author of the cognitive framework paper, which this hackathon ties into and which we'll be talking about later today.
Hi everyone, my name is Oren Kelly. I'm a product manager also on the Gemini evaluations team and co-author of the paper as well. And yeah, great to have you all here and looking forward to this live stream.
All right, thank you guys. So we have a packed agenda for today. We're going to start with a few minutes of just welcome and housekeeping, and then I'll do an intro and some updates on Kaggle benchmarks, as well as a recap of the hackathon itself. And then finally, we'll spend most of our time in sections 3 and 4, but we'll have Ryan walk through the paper, as well as what we're looking for in the hackathon. Along the way, please add your questions to the live chat. We'll be collecting them and answering them at the end with the live AMA. So some rules here. So only the presenters, the 3 of us, will have our mics turned on. Number 2, if you have a question, again, please ask it in the chat. We won't be able to answer specific questions about your benchmark, only about the paper, hackathon, or Kaggle benchmarks as a product. The reason is that we want to make this as generally useful for everybody here today, and that's the best way we can ensure we do so. Number 3, we'll shortlist and select the questions, and they'll be shared with the presenters, where Oren will help facilitate the AMA at the end. Number 4, again, a recording will be shared. And number 5, and most importantly, please be respectful in the chat to the presenters and your fellow participants. We're all here to learn, and we're all here to have a great time and ensure that we have the best outcome for the hackathon together. With that, I will transition to an update on Kaggle benchmarks and the hackathon. So if you haven't noticed already, OpenAI models are now available in Kaggle benchmarks. We just shipped it last night, and so you'll be able to see it in the model selection panel when you are at your task. You can see we have a couple of the closed models like GPT 5.4 and also a couple of the OSS models. So if you want to run these models on your benchmarks, you can do so now within the quota that you've been given. We've also been shipping lots of changes over the past couple of weeks. You probably have already seen our new model selection panel that makes it much easier for you to find, discover, and select the models that you want to run your tasks on. And we've also added automated notifications in benchmarks itself, so you can follow benchmarks that you care about when there are new updates to models or new versions of the benchmarks that are available. You'll get notified via web and email when you do so. We've also added some support for rich metadata in the SDK itself. So this will really open the door for you to conduct much more interesting analyses. Even as you run the benchmarks, you'd be able to plot it against different metrics like token usage, costs, and also latency, giving a much deeper dimension to the analysis that you're running. So all this information is available in our GitHub repo if you want to start using it with the SDK. Finally, we've also made it much easier for you to navigate through the benchmark page itself. So if you look at the GIF that's showing right now, we've made it much easier for you to add and to create a task from the benchmark page. And we've also made it default imports of models. So when you bring a task into your benchmark, we show you the list of models that the task was run on, making sure that when your benchmark is set up, you have all the right models in place, and you don't have to manually add the models one by one. More recently, we've also shipped cross-user runs. It's not relevant for the hackathon because all the tasks within your benchmark should be created by you. But more generally, after the hackathon, you can basically run tasks that were created by other people on models that haven't yet been evaluated. One example is that with the release of OpenAI models, you might see a task that you care about that hasn't been run on the GPT models, and you can now do so even if they're owned by somebody else. And you'll be using your own quota to do that. Fourth and finally, we also have task versioning introduced. I saw a lot of confusion in the discussion forums over the past 2 weeks about, hey, why is the task not matching what's in the benchmark? And the reason is because of different versions. So you might change the task version, but we don't automatically update the benchmark. Now we make it super clear what task version your task is in the benchmark, and we make it a one-click effort to be able to update the task itself. All right, enough of the benchmarks product updates. I know you're all here for the hackathon info and for all the secret insights you're going to get. I'm going to do a quick recap of the hackathon before I hand it over to my colleague, Ryan. So again, we're about halfway through the hackathon right now. We have 2 weeks to go before it's submission time. Once submissions are locked in on April 16, we will start the clock for about a 6-week judging period, give or take. We have an incredible lineup of judges, including many, many GDM researchers and academic leaders in the field. So your work is going directly to them, and we will have humans reviewing every submission that goes to them. So please spend time to refine your submissions and read our evaluation rubric closely. We've given a lot of guidance in the evaluation rubric itself and also the templates for the write-ups itself. So please take the time to look at them, read the sample that we've provided. If you look at the bottom right-hand corner of this slide, we have a sample project for cross-modal binding. It gives you an idea of what we're looking for in terms of the write-up structure and template itself. For the actual submission, we have a write-up with a benchmark attached to the write-up. Please remember that every write-up and benchmark should focus on a singular track, and you can have multiple tasks within that benchmark itself. I say multiple because it depends on how you want to structure a benchmark, but ideally, multiple tasks will make it easier for us to read the benchmark and understand what it's about. If you've accidentally published your benchmark publicly, that's fine. We won't penalize you for it. We just, for your benefit, had requested for it to remain private. What we'll do is that after the submission deadline, we're going to publish all these benchmarks to everybody so everybody can see them, and for our judges to be able to review them after the deadline has passed on April 16. With that, I will hand it over to my colleague, Ryan, who will go through the paper in detail. Ryan?
Thanks a lot, Nick. So yeah, we'll be doing a deep dive now into our new paper, Measuring Progress Toward AGI, a cognitive framework. And in this paper, next slide, please, we try to understand what are the components of human intelligence that are going to be relevant for AGI, and how can we divide up intelligence in a way that allows us to evaluate it in robust ways. Next slide, please. And so in the paper, we lay out 10 high-level cognitive faculties or cognitive abilities that evidence suggests are really important for intelligent behavior in humans. And of those, which you can see here, the hackathon focuses in on 5. So those are attention, learning, metacognition, executive functions, and social cognition. And these are 5 areas where we think that existing benchmarks, or there's kind of underinvestment, or the existing benchmarks are not as high quality as we need them to be if we really want to measure progress towards AGI. So we're going to now do a bit of a deep dive into each of these 5. Next slide, please. Starting with learning. I think it's a pretty simple concept. We all understand learning in a general level. It's the ability to acquire new knowledge, new skills, or sometimes it might be new behaviors. And that could be through things you experience. It could be through explicit study, maybe by observing other people or being taught. And this is something that historically models have been pretty good at in some contexts. There's this idea of few-shot learning, which has been around for a long time. But it also seems like when it comes to learning more complicated skills or knowledge, that the models seem to still struggle with this in some contexts. And I think that a lot of the benchmarks that we currently focus on don't really even touch on learning at all. So I think it's a really interesting area of exploration, especially as the models start to develop kind of more persistent memory and longer contexts and things like that. And so I guess a couple of features when we're thinking about evaluating learning, what we need to first make sure we do is that we're not just tapping into something that the model already knows. So if we're just asking a trivia question like, what is the capital of France? The model probably already has some information about this. So just asking a question like that isn't going to tap into learning, even if we then start giving the model some information. So the first thing we need to make sure is the model actually does badly at whatever task you've given it without the actual learning or information or experience that you give to the model to help it learn. So you should make sure that whatever the task is in a zero-shot context, the model does badly. But then you show, okay, once you give the model some opportunity to learn, now it gets better at this task over time. And so I think this is a really interesting form of benchmark. It kind of is a bit of a departure from the way a lot of benchmarking is done. And I'm really excited to see, what cool ideas you come up with. There are many different subtypes of learning that you might want to try and tackle with your evals. And I guess a meta level point here, which is that you might have a benchmark that taps into one of these specific sub capabilities. And in the paper, you'll see that for some of these, we even break it down even further. Or you might actually combine multiple within learning and have tasks that tap into different parts of this. And that's kind of a judgment call for you to figure out how easy it is to actually benchmark these different components. And what I would say as a general rule here is, if the tasks all have a similar kind of structure, then it maybe makes sense to bundle them together. But if you're just pulling together like very disparate kind of tasks, then maybe those might be better off as like separate benchmarks. But it varies from case to case. And so specific subtypes of learning, we have concept formation, which is really the model's ability to understand new kind of features or categories or schemas about the world that it didn't already have. We can measure associative learning, which is the model understanding the relationships between events. Causal reasoning is a kind of associative learning as well here, or relies on associative learning. Reinforcement learning, which you're probably very familiar with, how the model learns based on consequences of its actions, getting rewards or punishments. Observational learning, learning from others, learning by watching or seeing a display of someone else perform a skill or task. And procedural learning, which is like broadly the model learning skills. And finally, language learning, which I don't know how relevant that will be here, because it's obviously very difficult to know what existing knowledge the models have about language, but there might be ways of tackling this as well if we do some kind of pre-post learning test. And so, yeah, that's learning. Next slide, please. The second category we're interested in is metacognition, which is like kind of the model's awareness of its own processes, its own capabilities or limitations, and its ability to actually control those processes in a way that helps it perform tasks. So typically these kinds of evals involve the model performing some task, maybe taking some actions, maybe answering a trivia question, for example. But then you have some other question or task that's trying to measure how well does the model, have awareness of how well it's doing on this task, or have awareness of its capabilities. So like a classic example of a metacognition task is a confidence question. And then you try to understand how well calibrated is the model's confidence that, are you going to get this question right? Or did you get this question right or not? So we're not just measuring how well the model does a task, but measuring how well it understands its own capabilities. And so there's like 3 different components of this process. The first one is just general metacognitive knowledge. So in a general sense, how well does the model understand its own limitations in different ways? Then there's the monitoring aspect, which is as the model is performing a task, how well does it understand how well things are going? Does it understand, okay, oh, this is something I don't know? And we've seen a lot of cases where systems can be overconfident in their performance in different ways. And I think that's really a metacognition area. So I think this is a very important area of investigation for models today. And then the final one is metacognitive control, which is really about when the model realizes something's going wrong, or realizes maybe it's going down the wrong track. Its ability to correct that, to change its pattern, to change its actions, maybe change its focus, and choose a better strategy that's going to help us course correct. So again, really excited to see what we can build here. I think this is a super important area. Next slide, please. Third one is attention, which is, I know it's a loaded term in the world of transformers, but essentially here what we mean is how well a system can focus its cognitive resources on specific aspects of its environment, maybe different stimuli in the environment, different information that the model has received. It could also be how well it focuses on specific thoughts that it has. And I think, again, here, there's a really important case we need to avoid when designing these evals, which is we need to avoid evals where the model can simply look up answers in its context. Or if we're really explicitly telling the model, hey, now pay attention to this. Because then, the way that these systems are structured, it's when they're explicitly told to shift their attention, maybe they can do so, but if we hadn't actually asked them to do it, would they be able to navigate their attention in a way that's useful? And so 3 types of attention in particular we want to try and tap into. One is capacity. So this is basically how much information can the system focus on all at the same time. And this could be within text context, or it could be multimodal as well. And here it's not so much about just making the context bigger and bigger and bigger, but it's about how much information at the same time does the model actually need to pay attention to in order to do the task. So often this requires kind of forcing the model to use information in ways that require manipulation, or requiring the model to actually pay attention to multiple things at the same time. Second part is selective attention or attentional control. And this is really about how well the model is able to focus on specific parts of its input and ignoring distraction. I think one thing we've seen a lot of is if you take an input, which the model does pretty well on, and then you add some irrelevant information around it, you can change the system's performance quite a lot. And that's evidence that maybe the systems struggle to inhibit information that's not relevant to their task. So things like this are really interesting benchmarks that we can use to tap into attention. And then the final part is stimulus-driven attention, which is something that's not necessarily critical for AGI, but it probably is useful in that this is the model's ability to when a new piece of information or object appears in its environment, its ability to direct its attention towards that information in a way that's useful. And you can see that there's an interesting tension between that capability and the ability to ignore distractions. Like, you want a system that's able to ignore distractions, but also when something new does happen that's important, the model can orient and pay attention to that as well. So I think those 2 things are really interesting to kind of get at in tension with one another. Next slide, please. Fourth one is executive functions. And this is kind of a tricky concept in general in cognitive science, but it broadly deals with these what we might call higher order cognitive capabilities, where how well is the system able to actually direct all the other resources it has, which includes attention, memory, learning, in order to achieve goals. And so because of that, any tasks we build here are probably going to be quite complex. And I think a key pitfall here is make sure this is not just a general problem-solving task, because we have many, many benchmarks that give a complex problem and just require the model to solve it, but doesn't really tap into any specific component of executive function. So I think that's the key thing we're looking for here, is can we target very specific aspects of executive functions? So for example, goal setting and maintenance. How well can the model actually set goals and follow those over time? And again, here it's about trying to think about what are the right metrics that can really tell us how well the model's doing that specific thing. Planning is another great example. How well can the model, plan multiple steps ahead and follow those plans in a useful way? Then we have some capabilities about regulation. So this is similar to the attentional control in many ways. And in fact, attention is often considered an executive function, but essentially how well can the model inhibit responses it might otherwise take in a situation where it no longer becomes relevant. So a good example of this in cognitive science would be a task where you kind of get people in the habit of responding a particular way, but then suddenly something happens where that response doesn't make sense anymore. And how well does the system adjust and correctly adjust its behavior rather than just following that familiar pattern of behavior? Cognitive flexibility, also very important for creativity, which is about how well can the model switch tasks or modes of thinking. So giving the model multiple things to do and having to switch back and forth between them. And then finally about kind of processing or resolution. So conflict resolution, where maybe there are multiple contradictory goals that the model has, and it needs to try and understand, okay, how can I, navigate that complex mix of goals to select the best action in a given moment. And then finally, working memory, which is how well the model can actually manipulate information internally in order to achieve a goal. And again, this is quite similar to attention, in many ways, attentional control, but is essentially here the focus is specifically on, can the model in memory, without using tools, without offloading to some other source, how well can the system actually manipulate information, for example, when performing calculations or in other situations like that. So that's executive functions. Next slide, please. And then finally, shifting tracks quite a lot, we have social cognition. And this is really kind of an applied capability, how well the model is able to take all of its cognitive resources and apply those in social situations in order to correctly process information, social information, whether that's facial expressions, whether that's tone of voice, and then also reason about and respond appropriately in those social situations based on social norms. And this is obviously really critical for how the models interact with people. And a key pitfall here is that, social cognition is very context dependent, it's very culturally dependent. And so here objectivity can be really difficult. So one thing I would say if you're building a social cognition eval is, be very careful to watch out for cultural differences or stereotypes, make sure your data are ethically sourced, and try to be as objective as possible as you can. So there are some things where it's maybe, totally culturally dependent, but there are other things where there's probably a right answer about what is happening in that situation, and try to steer your benchmark towards those as much as possible. 3 specific types of social cognition we want to get at. The first one is social perception. As I mentioned before, this is getting at how well you can actually understand social cues from different kinds of information. It could be also text-based as well, like what is the tone of someone's speech, written speech, or it could be image-based as well. Theory of mind, which is about how well the systems can understand the intentions, the beliefs, the expectations of other people, and use that to explain their behavior or predict their behavior. And I think this is another example where, this is a really critical gap that a lot of the models have. And, as a user, it can be very frustrating if you try to tell a model to do something and it doesn't understand what your intention was. That's obviously can be very frustrating. So I think this is a really critical area of study, and we need better benchmarks here. A lot of the ones we have are based on these kind of very old vignettes that don't hold up very well in the modern AI age. And then finally, the social skills aspect. So how well does the model actually understand and navigate social situations? Can it cooperate with other people effectively when there's common goals? Can it negotiate with other people when maybe there's some conflicting goals? And then some other social capabilities, which might actually be problematic in certain circumstances. How good is the model at deceiving other people? Is really important to understand that to make sure our systems are safe. And persuasion as well is another one, where how well are the models able to influence other people's opinions or perceptions or thoughts. And these kinds of benchmarks, because of their social nature, they might require some interaction between different models or some very carefully crafted scenarios. And a multi-turn aspect is often really important there as well. Thanks. Next slide. Okay, and then finally, I just want to touch on a few general features of robust evaluations. There's kind of some more discussion of this in the paper itself, and obviously guidelines on the Kaggle website as well. But some things I want to touch on today. First of all, reiterating that we really want benchmarks or evals that are targeted to specific cognitive abilities. I think one of the things we've seen a lot is many of the tasks that are in our existing benchmarks, they kind of conflate together a whole bunch of these capabilities. And so if a model fails, it's hard to understand which of the capabilities is missing. So trying to isolate these capabilities as much as possible is really important. We also want to make sure we vary the tasks in difficulty. We want tasks potentially that are easy for humans and hard for AI systems. Those are interesting gaps that we might want to try and tackle, but also tasks that are really difficult for humans and test the limits of human capabilities. A question that comes up a lot is about okay, how big should an evaluation be? What's the right data set size? And it's really difficult to give a concrete rule of thumb because I think it really depends on the eval format. What I'll say here is that what we care about is not the number of items, but it's how robust the signal is. And I'll talk about that more in a second. But because people really, really want some kind of rule of thumb, I'll say anything smaller than about 100 items is potentially something that could be quite noisy. So you really need to think carefully about it if it's going to be small. And anything above something like 1,000 items, you're probably kind of getting diminishing returns in terms of how much signal you're gaining. And that also makes the benchmark very difficult to run. So I would say somewhere in that range is probably the sweet spot, but it really varies from eval to eval. Some evals, maybe 5 prompts is actually enough. If you have really, really robust signal, maybe you have multiple trials or a very long benchmark. So it really depends a lot. And then the last thing I'll touch on is you probably want to do as many robustness checks on your benchmark as possible as you're developing it. So like one common way to do this is with test, retest reliability. So if you run the same benchmark on the same model multiple times, how much do we see differences in performance? If we see like big variation in performance, then that may suggest maybe you need a bigger data set because the benchmark is quite noisy. So that's a useful thing to test. Another thing to think about is scaling. So do we see that larger, more powerful models score higher than smaller ones? It's not always true that this would necessarily be the case, but I think it is often an indication when you don't see that maybe something is going wrong with your benchmark. It's certainly at least a flag of like, okay, maybe I want to just make sure that everything's working properly. Keep an eye on if there are any prompt-specific effects or task-specific effects, I guess in this case. There's certain prompts which are swinging performance in one way or the other, which every model gets right or wrong. Maybe it's fine again. We want easy tasks and hard tasks, but it might indicate there's some issue with those prompts. And then really make sure, when you're thinking about how to evaluate the accuracy of an item, that the function or label that you have is accurate. You'll be surprised how often evals are giving us weird signal because there's a problem with the labels. So please double check all your labels, manually check them where you can. Obviously with today's models, using AI can also help a lot here. So hopefully these are some helpful starting points for thinking about quality and robustness. And with that, I'll hand over to Oren because I see there's a bunch of questions in the chat already.
Perfect. Thank you, Ryan. And yeah, thanks everyone for all the questions. It's great to see such engagement. So we have quite a bit of time remaining to go through these, so we'll try to answer as many as we can. But yeah, to kick on, and please continue sending them in. We'll keep monitoring the chat. So to begin with, and Nick, I'll hand this one to you. So it seems that Kaggle benchmarks is suited around pass-fail tasks. Is this expected to be the standard, or will there also be benchmarks with continuous output metrics?
Yeah, right now, it is mostly a limitation if you use assertions for pass-fail. You can specifically, maybe if you have an LLM as a judge, or the way you structure your assertions, you could have it in a way that it produces some like numeric float number as a result. So that's one way you could produce like a float number as a result on some continuous scale. So yeah, that's basically what our SDK supports right now. But I will also say that, on top of the benchmark itself, if you want to run additional analyses, you can always run them and include them in the write-up. And so you don't have to be constrained by the capabilities of our SDK if that's what you require.
Yeah, and I'll just add to that I think, especially a lot of these areas, there are interesting metrics you can get that go beyond pass-fail. So definitely encourage you to explore those as well, include them in your write-ups. And, even if not explicitly in the, the Kaggle Hackathon, these might be really useful for researchers down the line.
That's great. Yeah, thank you both. And yeah, on the pass-fail point, that was another question that a few folks had asked. Moving on then to synthetic data sets. Curious to get your thoughts, Ryan, on this. Like one of the questions is that based on the research paper, it seems like we should focus exclusively on real data when trying to measure these abilities, but would love to get your thoughts on the use of synthetic data for this.
Yeah, I would say I'm definitely not against the use of synthetic data as a general rule. I think that, the problem with synthetic data is quality and variety. And so, there are some times where maybe the synthetic data is giving you things that are not realistic or not very high quality. Obviously, those problems are getting less and less as the models become better and better. And then the other problem is variety, which is that depending on how you generate these data points, what you might end up with, if you generate many, many synthetic data points, you might end up with many tasks that are actually very similar, and they're not giving you a lot of individually useful signal. So my general approach, or what I would encourage you to think about is, are there ways you can maybe start with manual generation and then scale it up with synthetic data, or maybe the other way around, or both? Maybe you start with synthetic generation and then you use some manual verification as a way of narrowing that down into just the data points that you think are most useful. So I think some combination of the two is often the best approach.
That makes sense. Thank you, Ryan. The next question here is, if a submission should only focus on a single faculty and not multiple, is it possible to enter multiple submissions, each on a different faculty? So maybe Nick, you can share the answer to this.
Yeah, as part of the requirements for this hackathon, we've required that you select a specific track, and each track corresponds to one faculty. So the answer is that your benchmark must stick to one track and therefore one faculty.
Thank
But
you.
that doesn't mean within a faculty, as I mentioned before, you could include tasks that cover multiple sub-capabilities within that faculty.
Perfect. Thank you both. And then this question here, the 10 cognitive faculties of the framework interact non-linearly. So what are your thoughts, Ryan, on the framework, and is it intended to evolve to measure this cross-college resonance?
Yeah, absolutely. I would say, and we talk about this a bit in the paper, that these faculties all interact in many complicated ways that we don't fully understand in humans, let alone in AI systems yet. So I think definitely the framework is designed to evolve as we understand more. And I guess our hope is that we can, through benchmarks like the ones that, hopefully all of you will be building, try and understand these faculties more and then do more research into like how they interact with one another. And that's something I'm really, really excited about.
Yeah, plus one to that. And leading to the next question then on embodied intelligence. So curious to get your take on how the AGI framework maps to this, Ryan. So if a model passes all cognitive benchmarks in a digital environment, but cannot reason through real world physics, what is your take on this part?
Yeah, it's a great question. And I think it's like almost a very philosophical one. I think there are many different ways of thinking about what AGI means or what it looks like. I would say specifically to the kind of physics understanding part, I would say that definitely would count in my mind as a cognitive task. Understanding the physical world is still a cognitive thing. Now, there's a question more broadly about physical tasks, like, okay, maybe you have an AI system that can do anything you can do on a computer, but it can't lift a heavy rock. And should we say that's AGI, right? Or it can't play football. So is it AGI or not? And I think, again, these are very philosophical questions. The way I tend to think about it is like trying to remove intelligence from the physical capabilities of the system as much as possible. But again, there are many ways of thinking about it.
Absolutely. Thanks, Ryan. This one is another. So this is a question that's come up from a few folks here, and it's the fact that there are already known structures and tests for isolating these functions in people. And are we looking for implementations of those for LLMs, or are we looking for novel tasks? And if novel, why is this the case? And yeah, both Nick, Ryan, curious to get your thoughts on this.
Yeah, I think that looking at tasks from the human cognitive literature is a really good place to start. And I think a lot of good AI benchmarks actually do take that approach. They start with something we've already created for humans and then they adapt it. One thing I will say is that a lot of tasks don't easily map on one-to-one in the way you might expect. I think a good example of this would be associative memory tasks where I might give you a list of words and then a list of another words, and you have to kind of learn the pairings between these sets of things. And in humans, because once the list disappears, we no longer have access to it. We can use this as a test of learning and memory by asking people, okay, here's a word, what was the pair? But in current systems, if I give you that list of words and then later I ask you another question about it, the original pairings are still there in context. And so the model is not using its memory in the same way. It could just be looking up from context those associative pairings. So it's an example of how some of these tests don't map on neatly, but I don't think that means you shouldn't use them. I think adapting tests that we already have is a really valuable thing to do, and we shouldn't reinvent the wheel where we don't need to.
That makes sense. Thank you, Ryan. A question here then, practically speaking, on uncertainty estimates. So should the benchmarks also include these uncertainty estimates, like variability across runs, or is a single run eval sufficient?
Yeah, I think, what I would say is the more testing you can do, the better. And I think this is where the report comes in. The more information you can give us about the different ways in which the system is robust, if you are able to run multiple tests, if you're able to run it on more different models, if you're able to test it, in various different ways, I think that is evidence of robustness, and so it definitely kind of falls under the criteria. But there's no strict rules about what you actually need in order to, to show that there's a robust benchmark, because it's also very benchmark dependent.
That makes sense. Thank you. And then the next question that I see here. So this is, they said, a question on how to format the submissions. Is a task intended to be an item, or is a task a subtest, so like a collection or like a set of items, essentially?
Yeah, I can answer that. So the way we've structured the primitives for the benchmarks product is that a task is meant to be a unit of problem. Obviously, if you have like 500 questions, you probably don't want to have one task per problem, because then it becomes a bit unwieldy. I would suggest that a task should represent like the sub collection of the entire benchmark. So if you have, for example, different scenario types, maybe one task could have several questions belonging within that task, and then you might want to divide it up across tasks, so you have like a clear representation of what you're trying to achieve.
It's a way of thinking about this, Nick, that if you basically don't need any code changes in the task apart from the prompt text, then that should all be grouped together. Whereas if you have maybe more meaningful kind of code changes, then you might want to separate those.
Thank you both. The next one here is an interesting question. So can we pull data from public data sets and fine tune the questions based on the track?
Nick?
Yeah. Yes, I think so. As long as the license for the data set allows for you to be able to change the data set and to use it for some other use outside of what it was originally intended for. So just double check that the license of the data set allows and permits for that.
And I guess I would also add that I think in the criteria, there's a novelty component. So, depending on how you're using that data, that may impact how useful that benchmark is. If it's very similar to something that already exists, then maybe it's not going to be that novel and useful. But if you're taking just some public data and modifying it in a very new way, then I think that's a lot more meaningful.
Yeah. One more thing to add to that as well. I think there are a lot of data sets, even on Kaggle, where they would be prime candidates for something you might want to create a benchmark for. They just haven't been used in that way. And I think that goes for like any public data set out there. So we don't always expect you to create brand new or synthetic data. You could always repurpose and reshape it, like Ryan mentioned.
Yeah.
Perfect. And yeah, thank you all for keeping the questions coming in. We've got plenty more to cover. The next one here, for the write-ups, how important is it to present results across many models? So would a benchmark that only presents results on a few models be graded worse than one that presents many models, essentially?
Yeah, I can take that first, and then I'll hand it over to Ryan to complete the answer. So as part of the submission requirements, we don't specify exactly which and how many models you need to run the benchmark or task on. And we did that intentionally. I will say that we recommend that at least 5 models of varying sizes of different providers might yield more interesting insights, just because we also have a section within the rubric, or criteria within the rubric itself, for discriminatory power. So if you choose like all models of similar sizes from similar providers, you might not be able to see that difference that clearly.
Yeah, I agree with that. And I think, it really just comes down to how well are you able to demonstrate the utility of the benchmark. And I think it depends a lot on benchmark to benchmark, but more data is rarely a bad thing if you have the ability to get more.
Yeah, and on that point as well, but more on the task level. So someone asked, is 10 tasks enough, or should we aim for 50 plus? And I know you touched on this in your presentation, Ryan, but I think maybe it warrants a bit more discussion, because it's a fair question, and at least in my eyes, it will vary depending on the actual data set itself. But yeah, maybe we could like dive a little bit deeper into that.
Yeah, I think I'd reiterate what I said before, which is there's no hard and fast rules here. And I think it also depends a lot on how you define a task. Like many of you may have heard of this Claude plays Pokemon benchmark, right? Where you get Claude or another model to play an entirety of Pokemon, and that's one task, right? And now that's also an agentic task with many branching paths. So it might be unreliable if you just have one task, but in theory, there's no reason why you couldn't just have one very long task. And if it is reliable, you can run it multiple times and you get similar results, then that might be sufficient. So I think, especially in these cognitive areas where what we need is creativity, I think you shouldn't feel like, okay, I really need to just do 1,000 tasks in order for this to be useful.
Perfect. Thank you, Ryan. That makes sense. A couple of other questions here. One is on the evaluation of the submission. So maybe Nick, you can touch on this, and feel free to go into as much or as little detail as you like. But how are the submissions evaluated and scored?
Yeah, so we have a panel of judges. I think we might have like at least 10 to 20 right now. We will look at the rubric that we've shared very closely as we judge each submission, and we will give points based on the rubric that's been provided. So as you provide your write-up, as you work on your benchmark, please ensure that you're reading the details of the rubric itself and ensuring that we're compliant with that, and you're expressing that in a clear, readable way for us. As you can imagine, each person may have 20 to 50 submissions to review, each judge. And so like the clearer your write-up and your benchmarks are, the much easier it is for us to be able to perceive and understand what you're trying to convey and to be able to give it an accurate and precise score.
Perfect. Thanks for sharing. There's a question here on text-based submissions. So maybe Ryan, I'm curious to get your thoughts if you have them on this, but do you feel like text-based submissions can be as high quality as non-text-based submissions across each of these faculties?
Yeah, so if by text-based submissions you mean like text inputs, then I would say, again, there's no reason why that should be a limiting factor. I think there are many things we can do with text that are not yet explored in many of these domains. I would say that I think for some things, when it comes to, for example, social cognition, I think a lot of the historical existing benchmarks rely on one modality. And I think one of the problems we've seen there is it's not actually reflective of how the models perform in the real world. So I think there is some advantage there for sure in trying to think about having more complex or multimodal kinds of inputs. But for many of the others, I think text can work well. I think learning is another good example where you might want multiple modalities because we want to understand not just how well the model learns text, but how well it learns all different kinds of information.
And one comment about modalities. So right now we support text and image inputs for most models that support it. We're adding support as well for web URL searches and video input this week. And over the course of the next 2 weeks, you will see more support for other modalities. But at least start with text and image for the areas that Ryan talked about, and that would be a great start. You also have to realize that not every model is natively multimodal. So even if you, for example, submit video to like a Claude model, they might do frame sampling, and it's just like a different level of quality or a signal that you might get if you do videos with Claude.
Perfect. Thank you both. A question then here on, do you recommend explicitly designing benchmarks to expose specific failure modes, or should these just emerge naturally from the tasks themselves? Maybe Ryan, you may have thoughts on this.
Yeah, it's a great question. I think in general, I would say probably it's worth thinking about failure modes as an inspiration for sure. Because again, if you have a benchmark where every model is scoring 100%, then it's not going to be that useful. But I think there can be a danger in honing in on a failure mode too much, and then we lose the kind of broad sense of how capable the models are overall. So I think use it as inspiration, but try to also, one of the things we want to do with this hackathon and in general is broadly cover the model's capabilities in these faculties. So try to, evolve your set so that you have a mixture of difficult and maybe easier items so that you kind of cover the space well.
Perfect. Thank you. A question here then on the grand prize. So does it favor benchmarks that include a human expert baseline for comparison? So maybe to get your thoughts on human baselines for these evals.
Nick, do you want to take this one?
Yeah, I think this was also asked in the discussion forum. So we don't explicitly require that you provide human baselines because that can be extremely difficult to do at scale, especially if you're doing a novel benchmark with a novel data set. I don't expect you to go out and recruit 10 people to try this out. But if you already have some form of human baseline from some external research or some survey that was done, feel free to include that in your write-up. But we won't explicitly award bonus points way above the criteria limit just because you added that in.
Perfect. Thank you.
Yeah, and agreed. Like from a scientific perspective, in the paper we talk about how this is a really useful thing if you're trying to understand how capables are relative to humans. But even if you don't have any human baseline at all, we can still learn a lot about model capabilities. So I think it's definitely not a critical thing for this hackathon for sure.
Sure. And then diving deeper into model capabilities and I guess loss analysis, should we explain why models fail or just report the pass-fail itself?
Good question again. I think, again, the more information the evaluation gives us, the better. That's like what evaluations are for. They're for telling us about and helping us understand the models. So I think if there are ways of incorporating, information about model failures, I think it's useful. Because there are some failures which are not very interesting, and they just, the model's failing because the context is too long, so it just breaks, and that's not very useful. So I think it's worth at least looking into this, and then, if you have interesting things to report, then there's no harm.
Yeah, and to add to that, in the write-up, we have a section for insights where we sort of expect that you would look at the benchmarks and the results and kind of tease out what the interesting novel insights are for us, because it's going to be difficult for us to look through like hundreds of submissions and hundreds of prompts within those submissions to tease them out ourselves.
Perfect. And also on submissions, Nick, so can we keep adding tasks after submission until the April 16 deadline?
Yes, so as long as you've attached the benchmark, and I assume you mean you've submitted the write-up with the attached benchmark already, you can keep adding tasks to the benchmark. What we will do is that after the submission deadline, we will assign the write-ups with their attached benchmarks to the different judges, and the different judges will review those after the deadline. And so whatever you add after the deadline won't be good, because we won't look at them in time, but whatever you do before is fine.
Perfect. Thanks, Nick. And this is something that I saw came up a couple of times in the discussion forum as well. So maybe you can talk through this, Nick, as well, thinking around the community upvotes. So what that process, and yeah, if you could share more.
Yeah, I don't know if most of you have seen it, but after review with the other organizers, we've decided to remove community upvotes as a criteria. I think instead we replaced it with novel insights, and we've grouped it together with discriminatory power, moving from 15 to 30%. And the reason we took away community upvotes is that we've historically seen some behavior where there was some inorganic engagement farming, people kind of voting for each other in circles, and it wasn't in the spirit of these hackathons and competitions to enable that, because ultimately we want the submission and the chances of you winning to be entirely within your control. And this is not something that would be within your control for the most part.
Thanks, Nick. And then this is another interesting question. So will the winning benchmarks be made open source, or what is the plan for the winning submissions?
Yes. So I'm sure some of you have seen the submission guidelines about the CCO license with the actual write-up. So everything that is basically submitted as a write-up will be published under that license, and every benchmark will be made public after the deadline of April 16. And it will be under the Apache 2.0 license. So the answer to that is yes. There was a question about kind of derivative works, or like, works that were used in the write-up itself. I made a comment in the chat that we will circle back on that in the discussion forums. It's something that I'm consulting with the Kaggle competitions team on, and we'll be able to share more about the specific use case.
One thing I'll just add is, maybe one reason for this question is in the paper we talk about the importance of having good held out benchmarks. But what I would say is that right now, a lot of these, we don't have good public benchmarks either. And I think that's a really critical part of the evaluation space and community as well. And that's really the focus here, is like, let's get more public benchmarks we can use, we can get some signal, and then we can build on that and build held out sets from those in the future, or from in similar vein in the future.
Yeah. And to kind of, go off that line of thinking, the work is not done after the hackathon. The reason why we also want to make it public, open source, and easily accessible to you is that we want you to take inspiration from the work of your peers, build on it, improve upon it, and then do something much more than any single researcher and any single AI lab could do.
Perfect. Thank you both for sharing. And yeah, I guess there's still a couple of questions still rolling in, but in the meantime, maybe Ryan, I might put you on the spot, and a question here: what defines a high quality benchmark for AGI? Which is a very broad question, and feel free to approach it how you like. But maybe what might make sense is if you have any guiding principles, or maybe how you would approach a task like this at a very high level.
Yeah, I think all the things I said in my presentation, I think, are aspects of a high quality benchmark in general, and those specifically, I guess, the targeted component is useful for a high quality benchmark in thinking about AGI, or at least if you're thinking about a specific cognitive ability. I'm trying to think if there's any other characteristics of AGI specifically. I guess, again, the comparison with humans is important for AGI, but I think that in general, we have a long way to go as a community in just getting robust benchmarks in general. And I think, that's where I think the most of the gains can be, and just, thinking about what are the right things we should be measuring in the first place. And that's hopefully what this hackathon can help, help boost these areas.
Absolutely. That makes sense. Thank you. Another question here, are we allowed to publish results from our benchmark? So participants allowed to publish results from their benchmarks in academic papers after the competition?
I replied in the chat, but the answer is yes, you can.
Perfect. Great. Okay. Thank you very much. I think those are all of the questions that we've had come through that to answer today. And yeah, I'll hand it back over to Nick. Thanks everyone for asking all of these questions.
Yeah, thank you everybody for the engagement. We're 5 minutes past, but we really want to thank you for joining and participating in the hackathon, being so engaged throughout the entire process. The hackathon's still going to run for another 2 weeks, and then we'll have 6 weeks of judging, as I said earlier. So if you have more questions, please ask them in the discussion forum. I will try to answer as many of them as I can. And if you want to kind of check out the paper, like Ryan's work more, I'm sure Ryan can share more details about his socials too.
Yeah, I think the link to the paper is in the hackathon, so please check it out. And yeah, really excited to see what you all build. So thanks for everyone for joining us today.
Thanks, everyone.